Okay, number 33. Describe the transformation. So we see this x minus 5 here. Now it's in the function itself, so what that's going to do is it's going to move it to the right, or shift to the right 5 units. To verify, we could plug the equations in. 3 to the x and 3 to the x minus 5. And we can see that it moved over 5 units. Okay, number 34. Solve log base 6 of 6 squared equals x. So if you don't see the answer right now, all you need to do is rewrite it as an exponential. So 6 is the base to the x power equals 6 squared. Now since the bases are equal, the exponents are also equal, so our solution is x equals 2. Okay, so we have a log function. We want to find the domain, vertical asymptote, and x-intercept. Well, the domain for any log function are all numbers greater than 0. So the domain will be from 0 to infinity. Now, because of the properties of log, and that the domain doesn't include 0, there's a vertical asymptote at 0. And we write vertical asymptotes in the form of x equals the x-coordinate, which in this case is 0. And then the x-intercept, so really what we're saying is when is log base 4 of x equal to 0? Well, as an exponential, we get 4 to the 0 equals 1. Equals x. And 4 to the 0 is equal to 1. So the x-intercept is at 1, 0. In fact, all basic log functions like this will have an x-intercept of 1, 0. Okay. Number 36. We want to write it as a log of a single quantity. Now you have a couple choices here. I'm going to go ahead and distribute the 1/2 into the brackets. So I get 1/2 natural log of x plus 1. Half of 2 is 1, so I get plus natural log of x plus 1. And then I can rewrite that, but I won't yet. I'll just leave that as natural log of, or 3 natural log x. Then I'm going to go ahead and rewrite it with exponents. X plus 1 to the 1/2. Natural log of x plus 1. And then natural log of x cubed. At this point, we can rewrite it. X plus 1 to the 1/2 times x plus 1 times x cubed. Now, at this point, we can actually combine these. Remember, this is the first power. So it's the natural log of x plus 1 to the 3/2 power times x cubed. If you put x cubed first, that's fine also. Number 37, another log equation. So if we rewrite it as an exponential, it'll make it a little bit easier. So the base x to the 4th power equals 625. So we can undo this with the 4th root. Now, anytime we take a fourth root of a fourth power, it's the absolute value of x. Now, on the calculator, to do a fourth root, we have to use the general x root button, number 5. But we have to put the number in first. Just one moment. Okay, thanks for waiting. I have returned. Now, this is the solution to this, but we cannot have a negative log base, so this is an extraneous solution, and the solution is x is 5. Number 38. We have an exponential with a variable in the exponent. So, to get it out of the exponent, we can use either of our log functions. I'm going to use natural log. So then rewriting the left side, I get the quantity 3 minus x times natural log of 2 equals natural log of 565. Now at this point you could use the distributive property. I'm going to divide by natural log 2 instead. So 3 minus x equals the natural log of 565 divided by the natural log of 2. I'll subtract 3. And then I'll divide by negative 1. Okay, so there's my exact answer. Now, if at some point you decided to change it to a decimal, that's fine. Just give yourself about 4 digits of significance. So natural log 565 divided by natural log of 2 plus 3. Nope, I forgot the negative sign. Hold on. And I get about negative 6.142. Well, let's see if that works. I store that into x. Go back to our original equation. 2 to the power of 3 minus x. And we see that, yes, we did get the right answer because we got 565. So x is approximately negative 6.142. Last problem. $70,000 is invested, that should be dollars, in an account where the interest is compounding continuously. After 10 years, the value of the account is $125,000. What was the interest rate? So we're going to plug in the information we know. We know the end amount, $125,000. We know the principal, $70,000. We don't know the rate, but we do know the t. I recommend getting the exponential by itself. So we'll divide both sides by 70,000. I'm going to rewrite that as e to the 10r. So I get about 1.7857. So now, to undo an exponential with base e, we'll take the natural log of both sides. So the right side just becomes 10r. And the left side, about 0.5798. So then to solve, divide both sides by 10. And that's about 0.58 or 5.8%. So let's check our solution. We'll store that into x, 70,000 times e to the RT, and hopefully we get 125,000, and we didn't. Oh, I see what I did. Silly Mr. Purcell. He did divide it by 10 in his calculator, but he didn't actually, or did on the paper, but didn't do it in the calculator. So let's just retry that again. We'll store that into x. And we should get something really close. Yeah. So 5.8% is our answer. And that concludes the video. Thanks for watching.